So if you are wondering where is the materials found, I will be sharing a link in our chat soon so that you can access the materials online. Okay, so just give me a moment. Yes, correct. You can take a seat here in front or up to you because the worksheets will be here. Oh no. Hey, why you say oh no? Okay, you can take the worksheet in front. Pass one worksheet back. Pass one worksheet behind. Okay, you have to see through the introduction again, unfortunately. So you're eat dinner already? Yes. If you want to take snacks, just go and take snacks. No worries, open take snacks. That's all. Okay, yeah. Okay, back to the introduction. So my name is Mr. Clarence and I'm teaching E-Math and A-Math at OVERMUGGED Center. So I have 3 to 4 years of teaching experience. So I've been taking about maybe 30 plus students every year, and most of them are actually taking their national exams when they have tuition with me. So, but over here, I teach from Sec 1 to Sec 4. My Sec 3 classes are at Coven on Saturday for E-Math 12 to 2. A-Math are on Thursdays 5 to 7 and Sunday 10 to 2. Okay, so I have every batch, my students have about 70 to 75% distinction rate, and 80% of them have a jump of at least 3 grades. So meaning to say before they start the tuition, they are about, most of them are at the range of C5 to C6. And after their very first exam, they usually jump to either B3 or A2. Okay, very rare cases they jump to A1 because the jump is a bit too big within that short period of time. So other than teaching tuition, so I have been playing volleyball from primary school all the way to JC. So that photo of me and my teammates are when we won the A Division Championships in, I can't remember which year, but I was playing for Nanyang JC. So that was the year whereby we won the A Division National Championships. Other than that, in my free time, I will play Mobile Legends, but not as much anymore. Then I'm also a big fan of shows like Suits, Fast and Furious, and Harry Potter. Okay, so moving on, OVERMUGGED has 7 locations across Singapore with our 3 main branches at Kovan, Bukit Timah, and Marine Parade. So currently, this is the Kovan Center, which has 2 stories. So we have a Telegram channel for O-level students as well. So you can search up the channel on Telegram and join because resources will be shared inside. So all the free notes for O-level students. Sec 3 will also benefit because we have notes from chapter 1 onwards for subjects like A-Math, E-Math, Chem, and Physics. Okay, so these are our locations. The Bukit Timah, Kovan, and Marine Parade are the main branches. The remaining 4, they're actually just shared space that we rent from other places. Okay, so as a student in the past, I truly believe in consistent hard work. So now, even when I'm a tutor, I also believe that my students can do well as long as they put in consistent hard work. So, as long as you practice a bit of math every day, it's better than none. And it will definitely be easier as compared to doing 20 questions in one day, because that will be too tiring for you. Okay, so if you are willing to put in the hard work and do consistently every day, trust me, I think it's very easy for you to score A for A-Math and E-Math. Okay? So we are able to provide notes, topical worksheets, revision booklets. We have our own textbooks as well. And we also have test papers, mock papers for our students to practice, especially when it comes to exam periods. So our welfare here is pretty decent. We have a pantry at every tuition branch. So our pantry is over there in this case. And we usually order bubble tea and pizza for our students when we find a need to. So if, for example, for my regular classes, when they did well for WA1, I order bubble tea for them. And when they were very tired after school, then I will also order bubble tea for them.
They want to teach bubble tea. He's introducing me, just be quiet.
Okay, so anyways, so at Overmark, we allow our students to study here anytime they want, so they can just come here and study and not cram people in library, or if you have unconducive environment, and just come here to study. Okay, so these are our tuition rates. So for Sec 3, it will be under the O-level category. Each session is about 2 hours. So if you count, it will be 40 per hour for weekdays and $42.50 for weekends. Are you here for the Sec 3 EMF? Yeah, okay. You can take a worksheet here. Yes. Bio. WA2 revision event? Or are you coming from bio class? Bio class. Who's the teacher?
I don't know.
Yes. Because I don't think there's a bio class now. So yeah. So then who is Yep. Okay, so anyway, back to this, then the last slide is so my last slide is on the academic year. So we usually start every subject from November onwards to prepare you for the next year ahead. So for example, we'll start Sec 4 topics in November this year so that you can prepare yourself for the next academic year. So having said that, I will start the lesson now and cover on indices and coordinate geometry. So for those students online, you can go and access the documents using the link that I sent in the chat. Okay, solutions will be uploaded at the end of all the sessions. So I think this is the last EMAth session. So the solutions will be uploaded very soon. Okay. So first topic we cover on indices. So for indices, a few formulas that you must take note of is when you have the same base and you have the same power. At the end of the day, indices formulas, a lot of students struggle to remember because they find it very tedious to memorize. But actually, the one key thing you must remember is that you only can do something when either the bases are the same or my power is the same. So only when it's the same base or same power. If there is nothing that is the same base or same power, then essentially you cannot do anything. That's the first rule that you must remember. Second rule that you must remember is that you only can do something when it's a multiplication or division. So meaning to say if it's an addition or subtraction, there's nothing we can do. Okay, because there is no formula or no property that we have learned regarding addition and subtraction of same base. So we only can do when it's multiplication or division. So when you multiply same bases together, you add the power. Okay, don't make the common mistake that most students make. Most students will actually multiply the power together, but that should not happen. Okay, you only add the power together. An example on how to remember this is very simple. For example, let's say now I have 2 squared times 2 to the power 3. So to break down 2 square is just 2 times 2. And 2 cube is naturally 2 times 2 times 2. So here you can see that how many 2's you have? 5. Therefore, it's just 2 to the power of 5. And how you get 5 from your original equation is essentially you add the 2 powers together. 2 plus 3 equals to 5. That's all. Okay, so you don't multiply the powers together. So same thing for division. So you just need to remember one essentially, because times and divide, they're opposite of each other. So if you remember that multiplication is addition, you will naturally realize that division is subtraction, because addition and subtraction are opposites, just like how multiplication and division are opposites. Okay, and for the addition and subtraction of the same base, there is something that we can do actually, okay, which you actually learn this in sec 1, when you learn how to factorize. Okay, we all learn how to factorize in sec 1. So what is factorizing? Factorizing is taking out what's common. Okay, so between 2 to the power of 7 and 2 to the power of 3, what is common is actually 2 to the power of 3. And when you factorize, you introduce a bracket. What does bracket mean? Multiply. So at the end of the day, this becomes a multiplication, right? So if you are lucky enough, then you have the same basis, then you can multiply. But if not, in this case, you can just evaluate 2 to the power of 4 plus 1, which gives me 17. Okay, same thing when it comes to subtraction, you can factorize. So there is nothing you can do when it's addition and subtraction other than factorizing. So now moving on to when do you multiply your powers? Okay, you only multiply your powers when it is, okay, we look at the third table over here when it's a power. So when you see a bracket, okay, when you see a bracket, your powers actually multiply together. Okay, this portion, if you want to break it down, how are we going to break this down? Very simple. Let's say now I have 2 cube and I square 2 cube. Okay, my question to you is, what does square mean? Number, right? Which means in this case, it will be 2 to the power of 3 times 2 to the power of 3, exactly. And from here, we know that same base multiply, what do you do to the powers? Plus. So it will just be 2 to the power of 3 plus 3, which is 2 to the power of 6. So originally, from the question itself, you have 2 cube and a square outside. My final answer is 6. The link between 3 and 2 to reach 6 is essentially 3 times 2. Okay, so which is why your powers multiply when there's a bracket. So afterwards, there's power 0. Power 0, I think, is the easiest out of all the laws that you are taught. Anything that is power 0 will just be equals to 1. So even if it's a million, you apply a power 0 to it, it's equals to 1. That's all. Okay. Which also means when you see questions that want you to solve for the power, for example, let's say they say now 2 to the power of x is equals to 1. We know that anything power 0 will be equals to 1. Therefore, x is equals to 0, finish. Because anything power 0 is equals to 1. So when one side is 1, you just need to know that the power is definitely 0. This is how you make use of this power 0 identity. Okay, so initially at the start of the lesson, I said that you only can do something when either the power is the same or the base is the same. So we covered same base already. Now is when the power is the same. When the power is the same like this, both is m, we can actually combine the base together and multiply them. Okay, so an example, you want to break this down as usual. Let's say you have 2 to the power of 2 times 3 to the power of 2. Okay, 2 to the power of 2, when you break it down, it will just be 2 times 2. And 3 to the power of 2, when you break it down, it will just be 3 times 3. From here, you will realize this is my first pair. This is my second pair. So essentially, you can rewrite as 2 times 3 times 2 times 3, whereby this is my first pair and this is my second pair. And they are multiplying itself because 2 times 3 is the same as 2 times 3, which means you can rewrite as 2 times 3 squared. So when it's 2 times 3 squared, 2 times 3 is just equals to 6. So you can write as 6 squared. Okay, so you go back to initially how you started. How did I get 6 over here? It is just 2 times 3. Finish. And the power remains the same. So please do not multiply the power because there is no rule that suggests that. So the same concept applies to division, which is why I stated at the start of the class, right? You only can do something when either the power is the same or the base is the same. Any questions so far? Okay, so now moving on to my root and my reciprocal. Reciprocal, it just means negative power. So in this topic, we are actually learning negative powers as well and how to convert negative powers into positive powers. So we do the root one first because root is the easier one. Whenever you see a square root, the first thing that comes to your mind is that your power has to be a fraction. Okay, so your thought process should be like this. When you see a square root or any root, your power must be a fraction. When you have a fraction as your power, okay, you already learned in primary school, every fraction has a numerator and a denominator. Okay, so in this case, when your power is a fraction, you must first find out what's the numerator, followed by what's the denominator. Your numerator is always the power inside. Okay, so this is the power inside. Inside meaning inside the square root. And your denominator will just be your power outside. Okay, outside meaning the power outside of the square root. So your thought process should be like this. When you have a root, your power is a fraction. Your numerator is the power inside, and your denominator is the power outside. That's the easiest way to remember. It's the easiest and the most straightforward way to remember this. Okay, so meaning to say, let's say I have now x to the power of 2 over this. Okay, so follow with me the thought process. This is a root. It means my power has to be a fraction. If my power is a fraction, my numerator is a number, inside or outside? Inside. My denominator is the power, outside. Finish. Then you simplify your fraction, you will get this. That's all. Okay, so how I want to go through your negative powers is very simple. Okay, you must understand that when it's negative powers, let's say it's a to the power of negative m. Is this a fraction? Now, it's not, right? So if it's not a fraction and I want to write as a fraction, it has to be over 1. So how you can remember and deal with negative power is very simple. You want to turn your power from negative to positive, all you need to do is bring it down. Okay, you bring it down, on top, you take out a to the power of m already, you're just left with 1. And now because you bring from numerator to denominator, your power changes sign. So it went from negative to positive. Alternatively, if you want to change from positive power to negative, you just need to bring up. So when you bring up, it goes to the numerator, it just becomes a to the power of negative 2. Over 1 but you don't need to write it over 1. So you can just write a to the power of negative 2. So the golden rule you must remember when it comes to negative power is honestly, when you want to change the, okay, when power changes sign, flip the fraction. So every time you want to change the sign of a power, you just flip it. If it's at the numerator, you bring it to the denominator. If it's at the denominator, you bring up to the numerator. But just remember, when you bring to the other side, your sign must change lah. So you don't start with a to the power of -2 at the denominator, then you bring up, you still write a to the power of -2. So let's try this. Let's say if my question now is this. Okay, and the question requests for you to write your answer in positive index form. This A is power negative. How to make my power go from negative to positive? You bring down. This is negative. How to make my power from negative to positive? You bring up. Therefore, my answer, x squared over a to the power of 4. Finish. Okay, this is the easiest way to remember. Oh no, she's lost. Is there nobody on top?
I went out and it's not by.
Okay, sorry. Okay, sorry guys. Let me check. I will call him. You sit inside first. Sec what bio? Sec 3 bio. So confirm they said for you to come today.
Yeah.
Okay, you give me a moment. You sit down first. Okay, in the meantime, everybody, can you all try, you all try question A first. Oh yeah, I think there's a miscommunication. This class don't exist. Yeah, the class doesn't exist. The teacher exists, but the class doesn't exist. So it might be a miscommunication between the admin because the tutor wasn't informed as well that there's a short class today. So what you can do now, unfortunately, you need to go back. So sorry for coming all the way down and check with the admin whether this class is actually valid. The teacher is Jason, correct? But I don't think he has a class now at this timing. Other timings, yes. You text the admin. Yeah, text the admin. If you have the teacher's number, you can also text him lah. But you just check with the admin, like how come you are asked to come down on Thursday. Okay, yeah, so sorry. Okay, so now sorry, we go back to this question. Okay, so if you want to go through, you want to solve a question like part A, first thing you will notice is that the first thing that you'll notice in this question is that all my bases are not the same. And if you recall what I said in the beginning, you only can do something when the base is the same or the power is the same. In this case, it's none. So you have 3, 27, and 9. Okay, how to change all to the same base? Very simple. You have 3 different numbers. You look at the smallest one. The smallest one is 3. So naturally, you can change 27 and 9 into 3. The question will definitely put it in a way whereby you can simplify into the smallest number. So you will have 3 to the power of x times 27 can actually be written as 3 cubed. So you write a bracket like this because you are replacing 27 with 3 to the power of x. 3 to the power of 3. Without the bracket, a lot of students will write 3 to the power of 3x minus 2. But are they the same thing? No. So you do not write this. Okay, always keep the bracket. divided by, same thing, 3 to the power of 2, 4x. So from here, you will have 3 to the power of x times 3 to the power of 3x minus 6 divided by 3 to the power of 8x. And then this is multiplication, so my powers add. This is divide, so my powers subtract. Therefore, you will have 3 to the power of x plus 3x minus 6 minus 8x. You simplify this, you will get 3 to the power of negative 4x minus 6. Okay, and the question wants positive index form, which means I have to turn my power from negative to positive. So before we can turn our power from negative to positive, right, we need to do this thing whereby you factorize out the negative. Because right now, your negative is applied to 4x and 6. So unless you separate, then you can go and convert into positive index form. But if you don't want to separate, you can always factorize out the negative. When I factorize out the negative like this, it means that the negative is applied to everything inside this bracket. So later when I want to switch it up, I can just keep whatever I have inside the bracket. So recall again with me, you want to change down your your power from negative to positive. Is this a fraction? Which means it is over 1, right? So you can imagine there's an over 1 here, but you don't have to really write it down. For your power to go from negative to positive, you must bring it from the numerator to the denominator. So therefore, it will just be 1 over 3 to the power of 4x plus 6. Finish. Okay, so those that came from my AMF class know that I'm a very kiasu person. I confirm will give advice on how to check. This question is a simplified question. Your value got changed? No. So let's say you sub in x equals to 1 here, you will get a certain value, which is you will get 1 over 59049. If you were to sub in x equals to 1 here, what do you think you'll get? So you just sub in key calculator 1 over 3 to the power of 10. You should get 1 over 59049. So now that you have verified that your values are the same, it means that your value didn't change. So your answer is correct. Because it's a simplified question, your value shouldn't change. If your value change, it means something is wrong. Okay. Moving on to part B. Okay, so we go back to what I said at the beginning. It's either your power same or your base same. We look at my base here. It is 2, 6, and 12. Can you simplify them into a same one? How? Check calculator first. Cannot. Okay, by right cannot. So when you realize that you cannot simplify 6 and write in the form of 2 to the power of something, or 12 in the form of 2 to the power of something, it means you go the other route. What's the other route? Same power. Because it's either same base or same power. So if base cannot be the same, your power has to be the same. One thing you notice in all the powers is that they have a letter what? X. Very good. So you have 2 to the power of x divided by, this one is 3x, which means 3 times x, right? And if you recall, under what scenario would there be a multiplication of powers? There has to be a B. Bracket 6 to the power of 3 inside, x outside. Okay, why do I put it like this? For a very simple reason. 6 to the power of 3, I can key in the calculator. If you were to write 6 to the power of x and a 3 like this, you are stuck. There's nothing you can do. Because at the end of the day, if you recall, you want your powers to be the same. And in this case, the only common power you can establish is x. Okay, then from here, next one is times. This is 12x minus 1. Okay, your power is x minus 1. So if I want to separate into two different things, it will be 12 to the power of x times 12 to the power of, if it's -1. Okay, so that these two, when you add together, x plus -1, you actually get x minus 1. So now that you have reached this point, you will have 2 to the power of x divided by 216 to the power of x. 216 is just 6 cubed. Calculator will give you the answer. Times 12 to the power of x times 12 to the power of -1. So you will realize in the first 3 lines, my powers, they are all the same. If my powers are all the same, what can I do to the base? I can put all together. I just combine everything together, which means I'll have 2 divided by 216 times 12 to the power of x times. So same thing, your power must be in positive index form. Now it's -1. So how to make it positive? Right, as a fraction, right? So it's 1 over 12 to the power of 1, which means you can just write as 12. Okay, over, you'll realize 2 divided by 216 times 12 is the same as 1 over 9 x times 1 over 12. Okay, and you want to convert, you want to open up the bracket, right? Because you want to simplify. So this power x over here, does it apply to just 1 or just 9 or the entire thing? Entire thing, which means you can actually write as 1 to the power of x over 9 to the power of x times 1 over 12. Okay, because there's a bracket. If there's a bracket, means the power is applied to everything inside the bracket. 1 to the power of x is equals to 1. Only when the power is 0, then it's equals to 1. Okay, so no matter what power is, as long as the base is 1, you'll just get 1. So this is just 1 over 9 to the power of x times 1 over 12. Combine, you'll get this. Finish. Okay, because of time constraint, I won't go through everything. I only go through the 2 types that I talked about initially. What's the 2 types of questions that I talked about initially? Either yes, which is A and B. So which is part A or part B. So part C and part D, I won't go through. The solutions will be uploaded. Those that are here, you can actually just, I got print out the solutions lah. So you want, let me know. Okay. Moving on to question 2. Okay, question 2 is a bit different because this wants you to express your answer in negative index form, which means at the end of the day, you have to convert your power from positive to negative. So we look at part B. Okay, we look at part B. You have P square R over Q square times P cube. So since P cube is not written as a fraction, you can just write over 1. Okay, and if you are going to be dividing by a fraction, you learn this in primary school, how to divide fraction? Keep, change, flip. So I keep the first one, I change to times, and I flip my fraction behind. Okay. Then, when we combine the first 2 fractions together, numerator times numerator, so I have a p square times a p to the power 3. What happens to my power? Plus, so I'll just get p to the power of 5 r over q squared. Okay, times. If you notice, this power 0, does it apply to everything or does it just apply to q? It's just q. If it applies to everything, there will be a bracket. But in this case, no bracket. So anything power 0 is equals to 1. Therefore, I only have r at the top. Over. Now this one, there's a bracket. Means the power 2 is applied to everything inside. So that means I have Q squared and P squared. Okay, then from here you want to combine, you get P to the power of 5 R squared over Q to the power of 4 P squared. Okay, I got 4 because I add 2 and 2 together. Then from here you can further simplify and get P to the power of 3 R squared and Q to the power of 4. For this portion, you can just do your simple cancellation in primary school. P squared cancel, 5 becomes 3. That's all. Okay. Then over here, all my power is positive, but the question wants my power to be negative. So how do you turn your power from positive to negative? You just flip. So whatever is on top, you bring down. Whatever is below, you bring up. So I'll have Q to the power of negative 4 over P to the power of negative 3 and R to the power of negative 2. Finish. Okay. Very rare your papers will test you to write in negative index formula. Okay, but it is better that you understand how to convert your signs of the powers, which is why this question is here. Okay, next one for part C. Okay, in part C, we deal with inside first. Okay, same thing. This is a root. This is a cube root, in fact. So my thought process is always the same. When it's a root, my power is a fraction. Thank you. Then fraction got numerator, got denominator. My numerator is the power inside or outside? Inside. Inside got any power? No, means it's 1. Okay, because anything power 1, you get back whatever you have. Power outside is 3. Therefore, denominator is 3. Times this portion over here. What can I do to the powers? Multiply together, which means I'll get negative 3 over 2. Then I square the whole thing. So when you do this step by step, we simplify the inside first. Simplify the inside means what do you do to the powers? Since it's a multiplication, add. So you add together, you'll get y power negative 7 over 6 squared. Okay, then from here, same thing. Once again, there's a bracket. So the powers you multiply again. This time you'll get negative 7 over 3. Okay, and since they want negative index form, you already have it. Done. So just a quick recap, how to write this as positive. Flip away, what do I get? So 1 over y to the power of 7 over 3. Very good. Okay, always remember, if now you don't see a fraction, it means it's over 1. So when you flip it, you must still have a fraction because there's a numerator and a denominator. Okay, moving on to the next question. Okay, in the next question, we are solving for the unknown, which is the power. So your rules and all your concepts must still apply. Whatever I said initially will still be true here. You either make the power the same or you make the base the same. Choose either one. So when you look at 2, 1, 2, 5, and 100, okay, there is no way you can make all of it the same. Because you cannot write 1, 2, 5 as 2 to the power of something. Neither can you write 100 as 2 to the power of something. So your best hope is to have same power because you have 3x and you have x. Okay, so there's a common x inside. So how will you do this? It's similar to our question 1A. No, sorry, 1B, sorry. Yes, correct. So if I have a bracket, do I want the x outside or the 3 outside? X outside. So inside will be 2 cubed times 125 to the power of x equals to 100. Okay, then from here, my powers are now the same. which means I can combine my base. So when you have 2 cubed times 125, that gives me 1000. So I have 1000 to the power of x equals to 100. Okay, then now from here, there's a chance for us to make the base the same, because 1000 and 100, you can actually all write as 10 to the power of something. For 1000, it will be 10 to the power of, very good, 100, 10 to the power of 2. From here, if both sides have the same base now, which is 10, left hand side is 10 to the power of 3x, right hand side is 10 to the power of 2. Therefore, you can conclude that what? 3x is equals to 2. Okay, how to compare? Very simple. There must be an equal sign. If left hand side only got one term, right hand side must only have one term. And most importantly, the base must be the same. From then, all these conditions meet already, then you can combine your powers. So if 3x is equals to 2, means x is equals to 2/3. Finish. Okay, moving on to next part. Okay, now my bases are all different as usual. Very rare you will see same base in one question. So 81, 3, and 27. This one, is there a chance for us to make the base the same? Means you have turned all the base into? Very good. So 81 is actually 3 to the power of 4, which means you can write as 3 to the power of 4, then power x, divided by 3 to the power of x plus 2 equals to 3 cubed. So the first step is to always identify what's the smallest power you want it to be. Then ask yourself whether it's possible to write as a power of that. So if you are able to identify that the smallest number is 3, and you don't know whether 81 can or not, right? Just go and take out a calculator, go and try one by one. 3 to the power of 1. Okay, don't need try 3 to the power of 1. 3 to the power of 2, 3 to the power of 3, 3 to the power of 4. Until you see the number there. Okay, your questions will not be so difficult to the point whereby your power is 20 something or 2 digit. Maximum 7, 8. Okay. From here, you have 3 to the power of 4x divided by 3 to the power of x plus 2 equals to 3 to the power of 3. Okay, then you want to compare, right? Just now I say if you want to compare, there must be an equal sign. My bases must all be the same. But my last condition is if right hand side only got one term, left hand side must also only have one term. So I must combine these two together. How to combine these two together? So 3 to the power of 4x minus x plus 2, correct? Is this correct? No copy first. I ask, is it correct? Means got reason. Does the minus apply to just x or the entire thing? The entire thing. So you either put a bracket or you straight away evaluate on your own. Okay. So better to be safe than sorry, always write a bracket. Then from here, you have one term, same base, same base. You just need to compare. So 4x minus x, then minus 2 equals to 3. Which means 3x is equals to 5. So x is equals to 5 over 3. Okay, for my last question, you have 625 to the power 1 over k times 1/25 to the power of k equals to 1. So 625 and 25, you will realize that actually you can simplify both to 5 to the power of something. Okay, so 625 is actually 5 to the power of 4. Okay, and 1/25, you can write as 1/2. Okay, so you can just use a calculator to try that one. Then in this case, you combine the first one. What do you do to these two powers? Multiply. So I'll get 5 to the power of 4/k times. Okay, you don't want to keep working in fractions because you look at your left, you look at your right, no fraction. So if I don't want a fraction, this 5 to the power of 2 you must bring up. Then bring up already, the power becomes negative. Very good. Okay. Why I write 5? Because there's a power to it. Anything power 1 will give me 0. Will give me 1. What's this power over here? 0. Okay. So in this line, I write in terms of 5 because I want all my base to be the same so that I can start comparing. Okay. So from here, when you combine these two together, it's a multiplication. So you add the powers together. So you have 5 to the power of 4/k plus negative 2k. Okay, how do I get negative 2k? It is just negative 2 times k equals to 5 to the power of 0. Now left hand side one term, right hand side one term, bases are the same. There's an equal sign. You can write 4/k minus 2k is equals to 0. Okay, which means when you move your 2k over, you have 4/k equals to 2k. Then from here, how to continue? You multiply both sides by k, so you get 4 equals to 2k squared, which means k squared is equals to 2. Okay, but the question do 1k squared, the question 1k. So to go from k squared to k, what do you do? Square root. So other side you also square root. You just write this as your answer. Then what else do you write? No, it's only press calculator. When you square root a number, how many answers do you get?
Plus minus.
Yes, plus minus. So it's positive root 2 or negative root 2. Okay, and in this case, you want to write as a square root 2, it's fine. So if you already solve all the way until here already, don't lose that answer mark. Remember that square root always has plus and minus. Your 3 same school. Your WA2 haven't over. I saw you here yesterday, right?
Yeah, really.
No, you do every day. Okay. So now we move on. Okay. Let me go through question 5. Okay. Question 5 is a question that is tested in A math exponential and also E math indices. Because you will still apply your laws of indices. So it's not that it's anything too difficult or out of the syllabus, it is still there. So the first thing we can do is you must realize that the question said divisible by 18. If I'm divisible by 18, it means no remainder, correct? But you're not going to do long division. Which means at the end of the day, you must rewrite your answer as 18 bracket something. Even if inside is very ugly, like what x squared, y squared, or is this divisible by 18? Yes, of course I can cancel out the 18. So this is the final form that I want. 18 bracket something. Because bracket means what? Multiply. And the opposite of multiply is divide. So this is the form that I want. Okay? We look at my bases, 2, 4, and 2. You can convert all to 2, which means I'll have 2 to the power of 2x plus 2 to the power of 2x plus, what do you do to all these powers? Multiply. So I'll get 2 to the power of 2x plus 4. Okay, take note, this is a plus, it's not a times. So please don't tell me you can add the powers together. Okay, now the question is you continue first. So you have 2 to the power of 2x plus 2 to the power of 2x plus, over here I got one question. What do you do for your powers to add together? You multiply, right? So if you have two things multiplying together, like this, you will add the powers together from here to here. Can I go from here back to here? Can, right? So I have to separate my 2 to the power of 2x plus 4 into 2 to the power of 2x times 2 to the power of 4. Did I change my value? I didn't. Okay, why do you want to do that? Because if you remember what I said just now, in the beginning, we already know that we must have our answer in the form of 18 bracket somethings. And bracket means times. If we keep working with plus, 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 there's no way we can ever reach to a times. Okay, so from here, if you want to reach to a multiplication, you have to take out what is common. What is common in all these three terms? 2 to the power of 2x specifically, right? So this is common, common, common. So I take out 2 to the power of 2x. When I take out 2 to the power of 2x from the first one, what am I left with? I'm left with, for example, if I have, let's say if I have AB plus A, what can I factorize out? Then what am I left with? Exactly, there's a plus 1 there, which means when I take out 2 to the power of 2x from the first one, I'm left with 1. The second one, I'm left with 1. The last one, I'm left with, not everything 1. The last one has a what? The last one is times 2 to the power of 4, right? So if I were to take out 2 to the power of 2x, I'm left with 2 to the power of 4. This is why I highlight only the one that I want to take out. Those that is not highlighted is the one that's remaining. Same concept as this. Sorry? 2 times. What do you mean 2 times 2? Hey, don't laugh at her. She's asking a question. What do you mean 2 times 2?
The vector is 2 to the power of 2 to the power of x. So does that mean you multiply the base, which is 2?
You only multiply the base when the powers are the same, right? Are the powers the same? No, in this case, the base is the same. So what do you do to the powers? You add it means 2x plus 4, right? Did I start with 2x plus 4? So my values didn't change. Hey, it's okay, just ask the questions. I'm not laughing at you. Only she's laughing at you. Okay? Then from here, can press calculator? Can. You press calculator already, you'll get 18 bracket 2 to the power of 2x. Is this divisible by 18? Yes, because I can just cancel the 18 like that. Therefore, shown. Okay, this is the purpose. So understanding this portion over here is the most important part. You must remember, if you can combine two powers together, you can also separate easily. So don't be too rigid with the formulas just because you are taught that when you multiply, you add the powers together. Doesn't mean you cannot separate when it's an addition of powers. Okay, this will be very helpful when you have all these proving questions, just like in question 6. Okay, for question 6, I will let you all try and I give you all 5 minutes to solve. Okay, it's almost the same as question 5. So I'll put question 5 here for reference. I'll go through in 2 more minutes time at 8:30. Go through the question now. So same as the previous question, you are divisible by 7. Means at the end of the day, you must have 7 bracket something. Okay, why bracket? Because divide, the opposite of divide is times, and bracket represents time. Okay, so first thing first, you look at all the powers. N plus 2, n plus 3, n plus 4. My question to you now is, can I write n plus 3 as n plus 2 plus 1? Are they the same thing? Are they the same thing? No, not the same. Same or not the same? What's 2 plus 1? Then what's this? So they are the same thing. Why do I suggest this? Very simple. So just now, in the previous question, when we factorize, right, you realize that 2x is common. Because here got 2x, 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 but this is 2x plus 4. So you always choose the one that is smallest. When you come back to this one, if you were to rewrite all your equations as 3 to the power of n plus 2 minus 3 to the power of n plus 2 plus 1 plus 3 to the power of n plus 2 plus 2, you'll realize that everything that is common is this. Which means you can actually separate the remaining, right? Because when your powers add together, means you are multiplying. So it will be 3 to the power of n plus 2 times 3 to the power of 1 plus 3 to the power of n plus 2 times what? Thank you. Then from here, I write all the 3 to the power of n plus 2 in green for a reason. Because what can I do to them? Starts with F. Factorize. Okay. So you have 3 to the power of n plus 2. I take out already. What's left from the first term? 1 minus, which is 3, plus 3 to the power of 2. Okay. Then from here, 3 to the power of n plus 2, bracket this portion, you key calculator, you get 7, which is exactly what I want. Because this means 7 times 3 to the power of n plus 2. Okay. This is one method. If students factorize out 3 to the power of n, right? Is that what you did? You end up with 63 bracket 3 to the power of n. Right? 63 is equals to what? 7 times 9, which means I can write as 7 bracket 9 bracket 3 to the power of n, right? So isn't it the same as what I have here? Which means technically your answer is still correct. As long as you have brackets and you have a 7 there, you can just cancel the 7 out, which means you're divisible by 7. So don't need to worry if you got 63. Don't panic, don't stop there. Your goal is 7. By now, you should know your multiplication table quite well. 63 can be divided by 7. What's your question? This one, this one, this one. Oh, 9 is 3 to the power of
2.
2. And this is 3 to the power of n, right? Same base, right? Essentially, same thing, oh. Okay, so no matter which method you do, honestly, you'll still get the same answer. As long as you can prove to me that it's divisible by 7. Okay, if no more questions, I'll move on to coordinate geometry already because we don't have much time left. Okay, so now we move on to coordinate geometry. Those questions that I didn't go through, solutions will be uploaded so you can refer to them. And most of the questions that I go through are the difficult questions. So moving on to coordinate geometry, there's only a few things you must learn and understand in coordinate geometry. Okay, number 1, you must know how to find equation of straight line. Number 2, you must know how to find length of a line. Number 3, you must know how to find midpoint. And number 4 is area. Okay, gradient, all this I'm assuming you know since Sec 2. I hope you remember. Okay, so your equation of straight line is always in the form of y equals to mx plus c, whereby m is my gradient. Okay, so for those that don't remember how to find gradient, it's essentially y1 minus y2 over x1 minus x2. Okay, and c is my y-intercept. Okay, and to find y-intercept is when x is equals to 0. So this should all make sense because when x is equals to 0, mx is also equals to 0, which leaves me with y equals to 0 plus c. Okay, so now the question is how to find equation of straight line. Very simple. Let's say now you have a point on the line 1, 2. You know my gradient is 1, for example. Okay, let's say you're point A, and point A lies on the line. If I want to find the equation of the line, you know that your equation of line is always in the form of y equals to mx plus c. But in this case, if this point lies on this line, do I know a value of y, which is 2? Do I know a value of m? Yes, which is my gradient. Do I know a value of x? From here, c is equals to 1. Then you write your answer as y equals to x plus 1. Okay, remember x and y can always change. So they have to be the unknown that you have left. M and C are the numbers that you have to go and solve for. Okay, so I mean technically this is 1x lah, but you don't need to write the 1. So it's just x plus 1. Okay, so this is the method that you can use to find equation of straight line. This is the easiest. Okay, then every time you want to check whether the equation of line makes sense, you always find a point on the line, then you sub in. So for example, let's say I have the point 3, 4. To check whether this point lies on this line, if you were to sub x equals to 3 into this equation, according to this equation, what is y? 3 plus 1, right? Which gives me 4. Is it the same as this? Yes. Okay, then that's how you know that this point lies on this line. So you must sub in one value to calculate for the other to verify, not assume that I sub in x equals to 3, I confirm get 4. That's not the case. Okay. Okay, moving on to the next portion is just gradient formula, which is nothing special because it's just the formula you have there. Then if it's gradient positive means you're going up, gradient negative means you're going down. Okay. When m is equal to 0, means my gradient is 0. When my gradient is 0, if you recall my formula, my gradient formula is actually a fraction. For a fraction to be equal to 0, what must be 0? Numerator or denominator? Numerator. Denominator cannot be equal to 0. So if my numerator is equal to 0, what does this tell me about y2 and y1? They are the same. If y2 equals to y1 means did my value go up? Did my point go up? I didn't, right? If my point never go up means it's a flat line, it's a horizontal line. Okay, which is just parallel to your x-axis. Next one, when you are a vertical line, okay, vertical line is like that. For a vertical line like this, at this point is x1. At this point is x2. Are they the same thing? They're the same thing, right? Because it's a vertical line. Your vertical line equation is always x equals to a. So let's say this is a comma 4. This is a comma 1. My x values are always the same. My y value will change because 1 is lower, 1 is higher. If I were to find my gradient from here, my formula will be 4 minus 1 over a minus a, which means I have 3 over 0. You recall denominator 0 means fraction is undefined, which is why my gradient is undefined. Okay, likewise, you can go and memorize all this, but it should be something that is easy to understand. Okay, remember, denominator cannot be equal to 0. So if my denominator is equal to 0, it means it's undefined. So if you forgot, horizontal line equation is always y equals to a, whereby a is a constant. Vertical line means x equals to a, whereby a is a constant. Last but not least, if two lines have the same gradient, means they are parallel. Meaning to say, the two lines are something like this. Okay? And what you learn about parallel lines is that they will never touch, right? So let's say I tell you this. Line AB is parallel to line BC. Is this valid? But they share a point B. I thought parallel lines won't touch. Okay, this is valid if they lie on the straight line, which means this is A, this is B, this is C. This gradient is the same as this gradient, right? Because they are the same line. And they share a same point, which is B. Okay, this is how you explain whether three lines are on the same line or not. I mean, whether 3 points are on the same line or not. Okay, so put this down. For 3 points to be on the same line, okay, sometimes they will use the word collinear. They mean the same thing. Okay, you have two conditions. Number one, gradient must be what? Must be same. Second condition is they must share common point. Okay, and in the example that we use here, the common point is B. So just because they are parallel doesn't mean they lie on the same line. The second condition is that they must share a common point. Also, okay. moving on to the next part. Okay, when we talk about midpoint formula, okay, if you want to find midpoint, what's wrong? Okay, if you want to find midpoint, your formula for midpoint is the same as your formula for average. You learn average in primary school. Okay, how to find average? You add everything together and you divide by 2. Okay, so if you, it's like, for example, midpoint, the formula is like how, let's say on your MRT purple line, this is Kovan, this is Serangoon, and this is Woodley. So Serangoon is the midpoint of Kovan and Woodley because the distance is the same. That's the meaning of midpoint. Okay, so you want to find the point, the midpoint, you just find the coordinates of the two ends and find the average, which is why is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Okay, so to find midpoint, just need to remember average. And I think by now, all of you know how to find average. To find distance, the concept, the formula look very troublesome and complicated, but at the end of the day, the concept is something you learn in Sec 2 already by Pythagoras theorem. Okay, so let's say this is my first point, this is my second point. Okay, let's say this is x2, y2, this is x1, y1. Okay, you want to find the distance of this blue color line AB, right? So if you want to find the distance of this line AB, all you need to do is find what is the horizontal line over here, okay, and the vertical line over here. Okay, because this is going to be a right angle triangle. And a right angle triangle, if you want to find the longer side, all you need to do is use what? Step 2, we learn this. Pythagoras theorem, exactly. So if I know how to find this is your A, B, C, which gives me A square plus B square equals to C square, right? Now the question is how to find A. Okay, so let's say this point over here is x2, this point over here is x1, right? To find the distance, it will just be x2 minus x1. This is equals to my A. To find my B, over here is y2, over here is y1. To find the distance, it will just be y2 minus y1, which is equals to B. Okay, therefore, in your formula, this x2 minus x1 is my A. This y2 minus y1 is my B. So A square plus B square equals to C square, but I don't want C square, I want C. That's why there's a square root there. Finish. So you remember Pythagoras theorem, you will remember how to find your length of a line. Okay, the test for collinearity, I already go through just now already. They must be parallel and they must share a common point. Then the last bottom of the page, you have the shoelace method to find polygons. I'm not gonna go through that because that is taught in A math. So students that don't take A math, a bit unfair to them. Wasn't she on the A math day? Yeah, okay, but anyways, those that learn A math then can benefit lah. But those that don't learn A math, you won't benefit from this. So there's no point for me to go through. And there is bound to be better methods to find area. So I'll go through later. Okay, I will move on to the practice questions in a while. Okay, 1 more minute. Why you all keep laughing? Okay, so I move on to my first question. So I have the area of triangle is 8 square units. I have OA equals to OB. So these two lengths are the same. I need to find what is theta, which is the angle. So now in coordinate geometry, nobody teach you, right, how to find angle, right? So very simple. This is a right angle triangle because it's x axis and y axis. Right angle triangle means you can use what? No, trigo, sec 2, you learn trigo. Okay, so exactly. So if this is the angle I'm looking for, where's the opposite? OB. Where's the adjacent? OA. Are they the same length? If they are the same length, means to solve part A, tangent theta is equals to opposite over adjacent, which is the same as OB over OA. And since they are the same thing, by now, I think you all should know, same number divided by same number is just equals to 1. Thank you. Okay, so if the tangent theta is equals to 1, to find theta, it will just be tangent inverse 1, and you will get 45 degrees. Finish. So actually, one fun fact about this portion about gradient is, right, okay, let's say now, this is my x-axis, and this is my y-axis. Okay, if the question asks you to find for this theta, how am I going to find? Very simple. You draw your right angle triangle as usual. Where's my opposite? This one, right? Adjacent is this one, right? Essentially, if you recall, isn't this just y2 minus y1? And this is just x2 minus x1. Okay, assuming that this point is x2 comma y2, and this point is x1 y1. Right? So my opposite is just y2 minus y1. My adjacent is just x2 minus x1, which means if you want to write tangent theta, your formula will eventually give you a y2 minus y1 over x2 minus x1. And does this y2 minus y1 over x2 minus x1 look familiar to you? It's the formula for what? You know your head. Formula for gradient, exactly. So tangent is just equals to gradient. Finish. This is the most difficult question coordinate geometry can ask you. Okay, so just remember, tangent is the same as gradient. But if you're confused, always draw the diagram like how I drew out, then you can easily answer the question. Okay, any questions for this part? No? Okay, can. If I want to find the coordinates of A and B, I only have a few information. I only know that the area is 8 and the lengths are the same. If this area is 8, how to find area of triangle? Where's the base? OA. So half times OA times, what's my height? This will give me 8, right? So since OA is equals to OB, is the same as writing half times OA square equals to 8. Because of the fact that OA is equals to OB. From here, OA square is equals to 16. If OA square is equal to 16, means OA is equals to square root 16, which is 4. Okay, in this case, I know I said just now, square root always got positive and negative. But what is OA? OA is a length. Length cannot be negative, right? So you just ignore the negative and write positive 4. Now we can write, now we know the lengths. This is 4 units. This is also 4 units. So those that got ruler, you can just imagine. Let's say now you are at level 0. You need to plus 4 upwards. Which level will you be at? Level 4, exactly. So this value is just 4. So what's the coordinates of B? B will just be 0, 4, finish. Then for A, it will just be, you start at 0 here. You plus 4 towards the right. You will be at finish. That's why I say those that have a ruler, you go and look. Your ruler is 0, 1, 2, 3, 4, right? So it's horizontal. And your x-axis is horizontal. So when you move by 4 cm, you'll reach at 4. This is how you derive your A and your B coordinates. Okay, next part. For part C, you must find the equation of line AB. Equation of line is what formula? How does the equation of line look like? You don't answer. 1, 2, 3. Somebody. Who is the brave soul? Equation of straight line is y equals to.
X plus C.
So you say you don't know? Y equals to mx plus c. What is m? Gradient. So I must go and find the gradient first. So to find the gradient, it's just 4 minus 0 over 0 minus 4. Finish. You will get -1. If not, if you remember just now what I say, gradient equals to tangent, right? We know that my tangent is equals to 1. But this line is going downwards, which is why I have to put a negative in front. Okay? After you have the gradient, you want to find C. Do you have a C represents what?
Y-intercept.
Do you know what's the y-intercept of this line? Where? 4, finish. So your answer will just be y equals to -x plus 4. Then like I said, if you want to be kiasu during the exam, you can go and check. You know that points A and points B lies on this line. So if I were to sub, for example, for point B, if I were to sub x equals to 0, my answer will be y equals to -0 plus 4. What does this give me? 4. Is it 4? Yes. Therefore, the point B lies on this line. Then it will make sense. Okay. For part D, you want to find the length of the line AB even easier. Okay. Length of line follows what concept? Let's repeat. Sec 2 learned before. Pythagoras theorem, finish. This is the line I'm looking for. It's the longest side, right? Do I know what's this? Do I know what's the length OB? What? 4. Do I know what's the length OA? 4. Then to find the longer side, Pythagoras theorem, 4 square plus 4 square, right? But that gives me c square. But do I want c square or do I want c? Square the whole thing. 4 square plus 4 square. Finish. Your answer will be square root 32. You press calculator, leave your answer in 3SF. That will be 5.66 units. Hey sister, why you flip to the next page? Still one more question. The last question over here, put line AC is line AB reflected about the x-axis. And point C is the point of intersection between the y-axis and AC. So this is how my line AB looks like now. When you reflect about the x-axis, it means you flip down like this. So you just imagine your line from the top like that, you flip down. Which means it will now look like this when you flip over. Okay, so your x-axis is actually your line of symmetry. So therefore, if the length at the top is 4, means the length at the bottom has to be 4. But is the coordinates 0, 4? It's not, because you're going down, right? Thank you. So the answer is just 0, -4. Finish. That's all. This question very simple. Just need to imagine flipping it down. Today never take snacks. Nobody wants snacks. Okay, moving on to question 2. Okay, question 2, I know A, B, C and their coordinates. And so if you notice over here, A and B, they have the same y coordinate. It means what kind of line is it? Horizontal. Flat like that inside. Horizontal. So this is a horizontal line because your y values is the same. If you need to find the equation of line AC, what's the first thing I must find? What's the formula for equation of straight line? So what must I find first? M. Okay. So gradient of AC. So how to find gradient of AC is just 5 minus -2 over -6 minus -3. This will give me -7/3. Then if I want to find what is C, do you have a point that you can sub into this equation? A point meaning a set of values of x and y that will satisfy this equation AC. Do you have?
Yes.
Where? Point what? It's just point. It's either point A or point C. You can choose either one. Because as the name suggests, AC, right? So if I were to sub in C, for example, instead of writing y now, what can I write? So you can choose which one, -2 or 5? Negative. Okay, 5. So if I choose 5, means my x has to be -6. So 5 equals to, my m is -7/3. My x is -6 plus c. This will give me 14 plus c. Means c is equals to -9. You get c equals to -9. It's just y equals to -7/3x minus 9. Finish. That's all. You find c, you find m, you have your answer already. On. Okay, for part 2, if I have a point that lies on the line, it means the coordinates will satisfy the equation of the line. Which means when x is equals to k, y should be equals to, when x is equals to k, y must be equals to 1/3. So therefore, instead of writing y now, you write 1/3. Instead of writing x now, you write k minus 9. From here, you shift over and everything, shift, you get k equals to -4. Finish. Okay, this part I'll just skip the shifting part because I believe you are capable enough to do that on your own. I hope.
What?
Okay, next. You have to find the equation of a line that is parallel to AC. Parallel to AC means what? The gradient is the same. So do I know what's the gradient of this line that I need to find? M is equals to gradient of AC, right? What's gradient of AC? -7/3. And it passes through point B, which means if I want to sub in a value, I can only sub in point B because point B lies on your line. So if I were to use the point B, instead of writing y now, what can I write? So I have 5 equals to, instead of writing m now, what can I write? Instead of x, what can I write? 9 plus c. Finish. Okay, this 5 and 9 is your coordinates of B. From here, you get 5 equals to -21 plus c. So c is equals to 26. Therefore, my answer is y equals to -7/3x plus 26. Your y equals to mx plus c. Okay, once everything copy already, I'll erase the I'll clear the whiteboard. Okay, so now moving on to your length of BC. So if I want to find length of BC, the concept here you must apply is what? Thank you, Pythagoras theorem. Okay, length is always related to Pythagoras theorem. So this is my horizontal, this is my vertical. So technically this is my A, B, and C. So Pythagoras theorem is A square plus B square equals to C square, right? So now the question is, what is the length of A? Okay, very simple. How to find length of A? It will just be, you take one of the x values minus the other x value. Even if it's negative, it's fine. Because when you square a negative number, it becomes positive. So imagine, so example, I use -3 minus 9 squared plus my B. Okay, so this is -3 minus 9. For my Y value, it will be -2 minus 5. Okay, even if I have to do this, it doesn't matter. Then now, this is your square root, right? You key this in the calculator, you will not get a nice number. Okay? A good practice that you can have is when you're finding length of a line, and that this is not the end of the question, right? Because you still have part 5 and part 6. You always leave it in exact first. Exact means what? Square root of something. So you evaluate what's inside the bracket, you will get 193. So you write as square root 193 first, so that you can use this in your working in the future. Because if you use GSF, your final answer will be different by 0.1. 99% of the time. Then you will lose the answer mark. So working wise, try not to leave as 3SF. Okay? Usually you leave at 5SF. But if you can have exact, then leave exact. Okay, but you still need to present your answer. So you have to present your answer in 3SF. Okay, but have the exact one so that you can use in the future. Okay, the next part, you must find the area of triangle ABC. So I say just now, I'm not going to go through this method because there's a better method. There's always going to be a better method. I mean, you want to use this method for this also can, but for what? This is the area of triangle. Triangle, how to find formula of area of triangle? Exactly, half times base times height. If this is my base, okay, you choose your base to be the horizontal line for a very simple reason. Base and height must be what? Perpendicular. So if my base is a horizontal line, my height must be a vertical line. Do I have a vertical line there?
Yeah, right.
Which one? I draw already, technically. This is my vertical line. Okay, so if I want to find area of this triangle, okay, so for part 5, area of triangle ABC, it will just be half times base times height. And in this case, my base is the purple color line, which is AB, right? What's my length of AB? Without using the length formula. This is the horizontal line, which is -15, right? But got such thing as -15 length. You just write as +15. Okay, how you imagine this? Very simple. From here to here is 6. From here to here is 9. You add together, you will get 15. For your height, it's the same concept. From here to here is how much? 5. From here to here, 2. You add together, 5 plus 2, you get 7. Therefore, your height is 7. Half times 15 times 7, you will get 52.5 units squared. Okay, for EMF coordinate geometry, this question is damn common. There is a reason why they ask you to find BC, then the area. Because afterwards, you must find the shortest distance from A to BC. Okay, so what shortest distance? Does anybody know? By right, this is covered in your school textbook. So looking at her, I don't know how to answer. Does anybody know what the shortest distance mean? So I clear this. Okay, if this is the line BC, I want to find the shortest distance from A to BC. So assuming it's like that. This line over here, okay, in case you don't know, is always perpendicular. So now over here, right, if I want to find the line in red, let's just call it H. If I want to find H is perpendicular to BC. Can I use these two lines to find area of triangle? Yes, right? What's the from the half times? What's the base? Yeah, correct. Your friend turn the head like that, correct? What's the base? The base is. So remember, base and height. You want to use base and height for area of triangle, they must be what? Base and height must be what? Perpendicular, right? Can you see which two lines are perpendicular in this case? The one I highlight and the red line. So what's my base? What's the name of the highlighted line? The one I highlighted. BC. So half times BC times H is equals to my area of triangle. Okay. So two things to take home from here. Number one, you must always know that shortest distance stands for perpendicular distance. Meaning to say the line that is perpendicular to your base. Because in this case, it is BC, therefore your base is BC. Shortest distance always means perpendicular distance. And you already know the area of triangle. And you also know the length of BC. This is not by chance. This is on purpose one. You find BC, you find the area, you find the last part. So instead of writing BC now, I found length of BC in part 4, right? Now this is why I say write in square root form. So that you have the exact value and your final answer won't differ by 0.1. So instead of writing BC, you can write square root 193. Please write square root 193 instead of 13.9. Times H equals to the area of triangle. Do I know the area of this triangle? You all copy blindly, right? Those that shake their head. What is the area of this triangle?
2.5 units.
Finish, 52.5. So I got all the numbers except H. How to find H? 52.5 divided by 52.5 divided by half divided by square root 193. You key this in the calculator, your final answer will just be 7.56 units. 3SF. Because this is the final answer, there's no need for 5SF or exact form. You can just leave it in 3SF. Yes. Okay. So every time you see these kind of questions, you must always remember to use area of triangle formula. And your area of triangle is always half times base times height. Please don't come up with any other formulas on your own and tell me that the base and height can be two random lines. Base and height must be perpendicular to each other. Okay, so moving on, I will go straight to question 4. So question 4, the diagram a bit faint, but what you have on the diagram is line 2. And I have the equation. Okay, so, and this value, this number over here is 3. So the question said that line 1 is parallel to line 2. And line 1 passes through the point A. So if I were to find the equation of line 1, equation of straight line is always y equals to mx plus c, which means I must find a few things. I must find m and find c first. Okay, m is my gradient. L1 is parallel to which line? So if I know the gradient of L2, do I know the gradient of L1? Yes. So I got the equation of L2 over here. 2y plus x minus 6 equals to 0. For a straight line, if I have it in the form of y equals to mx plus c, will I know the gradient straight away? Yes, right? Because my gradient is just which letter? M. Is this in the form of y equals to mx plus c? No, so I'll be right. I only want y to be on one side. So everything else I shift over, which means I'll have negative x plus 6. Okay. Then from here, the equation is y, but you have 2y. So what do? Divide by 2. Y equals to negative half x plus 3, finish. Okay. If you have this, means my gradient is equals to what? Is this in the form of this already? Yes, what's m? Does it include the sign? Negative half. So my gradient is negative half. So now I know my gradient, I must find c. To find c, you always sub in a point. Which point do you sub in this case? Point? Line 1 passes through which point? Diagram is line 2, not line 1. Point A, right? What's the coordinates of point A? So instead of writing y now, what can I write? Instead of writing m now, what can I write? Instead of writing x now, I can write negative 2 plus c. This will give me 1 plus c. Therefore, c is equals to 4. Okay, I get c, I get m. My answer will just be y equals to negative half x plus 4. Finish. If I want to find point B is the x-axis, right? It's the x-intercept of line 2. So do I know the equation of line 2? Yes, right? 2y plus, okay, no, sorry, I didn't divide that. 2y plus x minus 6 equals to 0. At your x-intercept, how to find x-intercept? Y equals to 0, which means my equation, if this is 0, I'm only left with, so x is equals to, therefore B is 6, 0. Okay, then now, part C, if I want to find the value of k, given that coordinates of ck, 1 lies on L1. So my equation of L1 is this. If this point lies on L1, it means when I sub in x equals to k, what should I get for 1? What should I get for y? If the point lies on the line, will the coordinates satisfy the equation? Meaning to say, from part A, right, L1 passes through the point A, right, which is negative 2, 5. If point A lies on L1, when I sub in x equals to -2 into my equation, what should I get for y? Alright, you don't need to use calculator. Because if a point lies on a line, do the coordinates satisfy the equation? Yes. So my coordinates over there, my y is equals to for A. My y is 5, right? And x is. So if I were to sub x equals to -2 here, you evaluate this portion, you should get 5. So same thing now for C. If the coordinates C lies on L1, when I sub in x equals to K, what should I get for y? 1. So instead of writing y now, what can I write? 1. Instead of writing x now, what can I write? K plus 4. Then from here, you shift the 4 over, you get -3 equals to -½ k. Therefore, k is equals to 6. Okay, next portion for part D asked me to find the length of the line segment DE. So before you can even find the length of the line DE, you must find the coordinates of D and E. Can you go and find that? The key word here is in the line L1 intersects the x-axis and y-axis at points D and E respectively. Point D lies on x-axis, right? On x-axis, what is equal to 0? Huh? Y is equal to 0. Point D is a point that lies. No, D and B is not the same. Wait. The question say line 1 intersects the x-axis and the y-axis at points D and E respectively. So, okay. Let me just draw the line for you to see. L1 has the same gradient as line 2, right? Right? So will they touch? No. What's the y-intercept for line 1? From the equation of straight line, you can find what's your y-intercept, right? What's the y-intercept? 4. Which means my line will cut through 4. So you just draw one line over here. Okay, assuming this is your line. Okay, let's say this is L1. And the question already say, right? L1 intersects the x-axis at point D and the y-axis at point E. So over here where the line L1 intersects with the x-axis, this is point D or E. From the question. The question say you intersect the x-axis at point. So is this intersection with x-axis? This point. So this point D. Then what about this point? This is point E. Do I know what's the coordinates of this point already? For point E. Point E is just 0, 4. To find point D, if point D lies on the x-axis, something is equal to 0. What is this something? Y. Thank you very much. So to find point D, y is equal to 0. So y equals to 0, you sub into which equation? Line 1, because point D lies on line 1. So you will have 0 equals to negative half x plus 4, which means x is equals to 8. So D has the coordinates of 8, 0. Okay, always remember, if you lie on the x-axis, means y is equal to 0. If you lie on the y-axis, means x is equal to 0. Okay, so this will therefore be 8, 0. Okay, and I also know point B. Point B is 6, 0. And this is 0, 3. Okay, so I know these 4 points. So if I want to find the length of DE, okay, if I want to find the length of DE, it's just Pythagoras theorem. Okay, this point is E. This point is D. I'm finding the length, which is the one we made. Do I know what's this length? How much? Do I know what's this length? 8. So technically, to find the length of DE, it will just be 4 square plus 8 square, square rooted. Okay, you'll get root 80, which gives me 8.94 units. GSF. Okay. So as long as you remember that length of a line is related to Pythagoras theorem, it shouldn't be an issue for you to find length of a line segment or the length between 2 points. Okay. For the last part, you're looking for the area bounded by L1, which is the red color line, L2, which is the, okay, wait, I need to erase some stuff. L2, which is the black color line, x-axis and y-axis. So the trapezium that you're looking for is actually this portion. Okay, this is the trapezium that you're looking for. Okay, the one that is shaded now. This is what you're looking for. But honestly speaking, you do know the formula for area of trapezium, which is half times A plus B times height. But we're not going to do that here because we don't know what's A, we don't know what's B, and we don't know what's height. So you don't have to be always so rigid with using formulas for area of trapezium. This trapezium is the one that I shaded, and that's what I want to find. Can you see that this trapezium is inside of this big triangle? And what do I need to subtract away from this big triangle to get the small triangle? That's all. So if I want to find the area, you take big triangle minus small triangle, finish. And to find area of triangle is the easiest. It's just half times base times height. So for my big triangle, what's my base? Is the one I highlight in purple, right? The one I highlight in purple. So it goes all the way to point D. So my base is 8. My height in purple, it goes all the way up to point E, which is 4. Minus my small triangle. Same thing, half times base times height. My small triangle is the one in turquoise. So it goes all the way until, for my base is, what's my base for my small triangle? 6. What's my height for my small triangle? 3, finish. Okay, you press this calculator, you will get 16 minus 9, which means my answer is 7 units square, finish. Okay, you must put the units square because this is area, which means you must have your units. So always remember, just because they say trapezium doesn't mean you have to find area of trapezium using the formula. You can always make use of the diagram. So sometimes in coordinate geometry, it's good if you can draw the line, but use pencil to draw so that you can erase during your exams. Okay, so we have about 1 minute left. I won't go through another coordinate geometry question, but I'll go back to indices and go through this particular question that I realize is quite unique and different from what you usually work with. Question for part 1. Okay, this is the last question, then I will end today's session. Solutions will be uploaded online. Those physical I'll print out for you. So when we look at this question, we have to find the value of P and Q, which this is equals to this. So one thing you notice is that 81 can be written as what? Very good. Just now we actually got to do 81. Okay. 49 can be written as 7 squared. Which means if I want to write this equation now, instead of writing 7 to the power of P times 21 to the power of Q, I can write as 3 to the power of 4 over 7 squared. Then you realize there's this weird 21 there when everything is 7 and 3. So 21 can actually be separated into what's the relationship between 21, 7, and 3? 3 times? Yes, so I can write 7 to the power of P times 3 times 7 Q like this. Okay, then if you realize left hand side is a multiplication, it's not a fraction. Right hand side is a, if I don't want the fraction, how do you bring up my new denominator? The power must become from positive to negative. So I'll have 3 to the power of 4 times 7 to the power of negative 2. Then this power Q over here, does it apply to just 3 or just 7 or everything? Everything, which means I'll have 7 to the power of P times 3 to the power of Q times 7 to the power of Q equals to 3 to the power of 4 times 7 to the power of negative. Then from here, you'll realize you have the same base, 7, 7. Multiply together, what can I do to the powers? So I'll have 7 to the power of P plus Q times 3 to the power of Q equals to 7 to the power of negative 2 times 3 to the power of 4. So from here, you compare left hand side, right hand side. Q is equals to 4. P plus Q is equals to, what's P plus Q equals to? No, don't need so complicated. Left hand side got 2 things, right hand side got 2 things. This is 7, this is 7. So the powers must also be the same. So P plus Q is equals to negative 2. And since I know that Q is equals to 4, it will be just P plus 4 equals to negative 2. Which means P is equals to negative 6. Finish. Okay, for the second part, okay, it's even easier. It says hence. Hence means what? You must make use of the previous part. You look at the question you have now and the question you had initially. The right hand side is exactly the same, which means the left hand side must also be the same. You compare this and you compare this. What's P equals to now? Exactly, P is equal to 6P. And it looks a bit confusing because how come same letter but different number? Okay, we already solved part 1, which means part 1's P is actually, yes, I know, but what's the value of P in part 1? So it will be negative 6 equals to 6P. Therefore, P is equals to negative 1. And we know that Q is equals to what? 4. So this is the same as this. Therefore, you can conclude that Q plus 7 is equals to what? You compare the bottom and the top. The one I highlight, are they exactly the same? Are they supposed to be equal to each other? Yes, right? And what is Q at the top? 4, which means Q plus 7 is equals to 4. No, the Q is not the same anymore. The Q in part 1 is not the same as the Q in part 2. But the highlighted parts, they are the same. So for you to better see this, actually you can write 7 to the power of -6 times 21 to the power of 4 equals to 81 over 49. Like that you compare, it's even easier for you to see. So therefore Q is equals to -3. Finished. So you can see clearly here that your 6P is equals to -6, Q plus 7 is equals to 4. That's all. Okay, if no questions, then that will be end of today's class. Before you all go, can you all do this survey? Thank you. So those that do already actually don't need to do again. Actually, no, must do again. Sorry. Wait, copy finish already, right? Okay, once you do the survey, then you can go ahead. This is the survey. Just today even session. Already got 15 hello. Okay, then you can take the free revision booklets and you have fun. Yeah, do the survey. Thank you.